All right, example 5, write the equation of a parabola given 3 points. What is the equation of a parabola that passes through the points -2, 32, 1, 5, and 3, 17? So this example is different than the one that we did previously because we don't know the vertex. So that means we're going to have 3 unknowns. If we're using vertex formula, those 3 unknowns are going to be A, H, and K. But we're going to use standard form because it's a bit easier to manipulate than vertex form is when we're solving for 3 unknowns. So what do we know here? Well, we have 1 set of x and y, 2 sets of x and y, and 3 sets of x and y. So that's going to be important as we see when we start substituting these values in. So using standard form, which again is y equals ax squared plus bx plus c, we get the following equation. 32 equals a times -2 squared plus b times -2 plus c. So when we simplify that, that gives us 32 equals 4a minus 2b plus c. So notice we have 3 unknowns. 3 unknowns means that we need 3 equations. So that's why it's important that we have 3 sets of x and y. So using our other set of x and y, we get the equation 5 equals a times 1 squared plus b times 1 plus c. So we get 5 equals a plus b plus c. And making room here, whoops. We get our third equation by using our third set of coordinates, and that gives us 17 equals a times 3 squared plus b times 3 plus c. So we're left with 17 equals 9a plus 3b plus c. So we have the 3 following equations with 3 variables, which means we have a system of 3 equations in 3 variables, which we learned last chapter how to solve algebraically, but we're actually going to solve using matrices this chapter. So I'm going to really quickly just organize these systems together. We have 4a minus 2b plus c equals 32. A plus b plus c equals 5. And 9a plus 3b plus c equals 17. So we could solve algebraically like we did last chapter, but we're going to use matrices like you guys learned last year in math too. So let's set up our matrices. So we have our variable matrix, which is 4, -2, 1, 1, 1, 1, 9, 3, 1. And again, we get those from the coefficients of a, b, and c from our 3 equations. And then we have our variable matrix, which is ABC, right, our 3 variables, and that equals our constant matrix, which is 32, 5, and 17. All right, so going into our calculator, going into the matrix screen, we're going to edit matrix A, which is a 3 by 3 matrix of 4, -2, 1, 1, 1, 1, 9, 3, 1. Quit. Go back into our matrix menu, and we're going to edit matrix B, which is a 3 by 1, our coefficient matrix, which is 32, 5, 17. 32, 5, 17, and then quit. So we just entered in this matrix as matrix A, and this matrix as matrix B. So to solve the system, we use A inverse B. And I am going through this quickly, but again, it's because you already did this last year in Math 2. If you are struggling and you would like to meet me during my office hours to go through this more in depth, a little bit slower, be more than happy to meet with you. All right, so we go back to our matrix menu,